Did you find that in the group?
Um, okay.
I shared the worksheet in the group. Did you find that?
Not sure. Let me
Okay. Today we are going to talk about science. So let's go ahead. We'll be diving in more closer way to the matter as we were discussing matter only. So here is a kind of uh, contents over matter in a booklet form. So you may go reading from here. This will develop better understanding about it.
Mm.
Yeah.
As we look at our surrounding, we see a large variety of things with difficult shapes, size, and texture. Everything in this universe is made of material which scientists have named matter. The air we breathe, the food we eat, the stone, the clouds, stars, plant, and animal, even a small drop of water or a particle of sand, everything is a matter. We we can also see as we look around that all the things mentioned above occupy a space and mass. In other words, have they have both mass and volume.
Yeah. So this thing is very necessary. Anything which occupy space and mass. This is what we also discussed earlier, right?
Mm-hmm.
Yeah. They have both and mass and volume. So this is something we talked about because the thing which would be having mass and volume would occupy a space. Okay, now go ahead from here.
Since early time, human beings have been trying to understand their surrounding. Early Indians philosophers codified matter in the form of five basic elements: the Taj, Tava,
Panch tattva,
Panch, Tav,
tattva. Mm-hmm.
air, earth, fire, sky, and water. According to them, everything living or non-living was made of these five basic elements. Ancient Greek philosophers had arrived at similar classification of matter. Modern day scientists have evolved two types of classification of matter based on their physical property and chemical nature. In this chapter, we shall learn about matter based on its physical property, chemical aspect, and matter will be taken up in quick sequence chapter.
Hmm. Go ahead.
For a long time, school to
You
school
skipped the heading. Physical nature of matter. Matter is made up of particles.
physical nature of matter. Matter is made of particles. For a long time, to school have thought thought prevailed
Prevailed means something in
prevailed
trend, something in trend. Hmm.
Regarding the nature of matter, one school believes matter to be continuous like a block of wood, whereas the other thought matter was made of particle like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particles?
Particulate. Hmm.
Particulate.
All right. And this is also very important. You see, SI unit, do you know SI unit?
No.
SI unit is international system for measuring the things. Okay. So
Mm-hmm.
internationally, if you want to measure something, that the measurement unit you need to use that is called SI, international unit. Okay. So, international system. So the system which involves international measurements unit. So SI unit for mass is kilogram. That's what you may remember, right?
Mm-hmm.
And SI unit of volume is cubic meter. So this is what very important. You may also write SI unit of mass is kilogram. Yeah. Uh, DM, you may understand. Do you understand what is DM means? Mm.
No.
That is cubic decimeter, DM cube,
Oh.
cubic decimeter,
Okay.
DECIMETER, DM, decimeter cube.
So DM
Yeah.
is decimal.
No, not decimal, decimeter, DECIMETER.
E-T.
This is exactly equal to 1 liter. Do you understand the volume thing in mathematics?
Yes.
Okay. How many dimension it may include if we are talking about volume? 2 dimension or 3 dimensions?
Huh?
Do you understand what dimension is?
I think so.
What is dimension?
Dimension, like a 3D.
Yeah, 3D. So what does dimension mean? You
The
can state some examples if you want. Measurement of length, width, height of something. So length, width, height, these are dimensions. So in volume we
wait,
always have
height.
yeah. In volume we always have three dimension. Width, height, and length. That's why it
Mhm.
is mm, always in cubic form. But area is in squared form because that has only two dimension 2D. Have you noted it down?
Yeah.
Okay. There is an activity we may understand. So what does this activity says? Just go ahead with this. Read this about this activity.
Take a activity. Take a 100 ml beaker,
Beaker.
fill half the beaker with water, and mark the level of water. And dissolve some salt and a glass rod. Observe any change in water level. What do you think has happened to the salt? Why does it disappear? Does the level of water change? In order to answer this question, we need to use the idea of matter. That matter is made of particles. Where was there in the spoon salt or sugar has now spread to water. This is
Illustrated in
illustrated
figure 1.1.
in
This is 1.1. So this is how it is happening. Particles of water magnified millions of time. So
mm-hmm,
we also have used magnifier since we played a game last time, right?
mm-hmm.
And water, then in this water we can see the particles of the water. It is in liquid form, right?
Yes.
And then when we go ahead adding some salt into it, right?
Mm-hmm.
And after that we stir the water. Stir means we kind of mix, and then um after what stirring and then water and salt is mixed, these particles are going to be mixed, right? So when we dissolve salt in the water, the particles of salt get into the space between particle of water. So just understand this activity. It says like take 100 ml beaker, you understand?
Weaker.
No.
Yes.
Hmm. Beaker is this kind of thing. Let me show you. Can you see this search bar?
Yeah.
These kind of things. Okay, understand?
Mm-hmm.
So this is beaker. So in a beaker, it is said like take how much water? 100 ml water. And then it is saying fill half the beaker with water and mark the level of water. We will just fill the beaker and we'll mark the label. Like for example, this is the beaker and we have filled till here. Let's see. This is the beaker and we have filled till here and we have marked it till here like this. Hmm? Till 100 ml we have filled. You
Mm-hmm.
see this or not?
Yes.
So till 100 ml we filled. I'm saying here till here. Till here we have marked. Okay. All right. Now it is said that after marking it to the level it has been filled, we may do what? We may then go by adding salt or sugar into it. Okay.
Mm-hmm.
So we may add what? Salt or sugar into it. So what would happen? Like fill half the beaker with the water and mark the level. Suppose we have filled 100 ml, then we'll mark the level. Dissolve some, or we have filled 50 ml, whatever mm, the water amount is capped in the beaker. Then we'll mark it, and then we'll be adding salt or sugar, one of these, with the help of a gas rod, and observe any change in water level. So just tell me, if we are adding sugar or salt into it, the level of water would change or not?
Mm, no. Yes.
Hmm. We must do it by experiment. Do you have a transparent glass near you?
Um, I have like wait. I'm gonna go get it.
And water as well, water and sugar, Charis or salt. Okay.
Can I use like this thing?
Show me. You are on blur. So firstly, remove your blurness from the background, then I can see properly. Click on the video and right hand side. Blur my background is ticked, then that untick it.
Wait.
Near the mic at the right hand side.
Near the mic.
Yeah, click on the video. Have you click on the video? Yes.
It wouldn't.
Yeah. Are you taking it on tablet or laptop?
Tablet.
Okay, then there would be another option. More and then setting. Okay, no problem. You can do this. So you can show me your glass, whatever you've taken. Once again, Cherish. Cherish, are you there? Cherish.
Okay.
Yes, you're visible. You can show me your glass once again.
Um, how do I unblur background? Okay.
Yeah, no, that's perfect. Fine. Show me your glass once again. Okay, you have this. This has measurement unit. Yeah, it is having.
One
So,
m 100 ml, right?
yes. And do you have salt or sugar with you and
Yes. I
water? Please
just
bring that. Water, salt, or sugar. One of these. Salt or sugar, and then plus water. Okay.
okay. Does it have like tap water or like drink water?
Any water. Any
Okay.
water. Tap water.
Okay.
Yeah.
Now what? Add salt.
Yeah. Water is filled.
Yes.
To how much extent?
100 ml.
That is marked at that level, right? Perfectly at
Yes.
100 ml.
I
Perfectly.
yeah, I think so.
Okay. All right. Then add what you are having, sugar or water? Sugar,
Salt.
salt. Okay. Add 1 spoon of salt into it.
Wait, I need to get a spoon. And then stir, right?
Have you added it? Now notice the
Yes.
level has raised or not.
Um, yes, a
Now
little.
now stir it. You can do it in front of camera too.
Yes. Mm, done.
So what do you notice now? The level is the same or it has raised.
Raise a little.
Okay. You have mixed it properly.
Oh, there's still a little bit. Yeah, I think I mixed.
Now it is completely mixed. Can you show it to me? Yeah. And the level you filled, it was the last line, red line, right?
Yeah, this.
So how much difference do you see? Is it the same or little raised
Uh,
now? Is it same now?
I think so.
And earlier it was little raised.
Yeah.
Okay. Now keep
Yes.
your things aside. So after observing this stuff, this experiment, what do you understand? When you are adding salt into the water, it slightly raises its level. But when you are mixing it, when you are stirring it, the particles are being mixed with into it, and the level seems to be at the same extent where you kept the water. So why did it happen? Can you explain it to me? Do you think? Can you explain, or I shall help?
Um, can I try?
Yeah.
So I think like um it raised because that time it was like sitting at the bottom, but now when I mix it, it's like dissolve.
Mm-hmm.
So it's going to be the same.
So where has salt disappeared? Where has it gone? When
Mhm.
salt is dissolved, okay, let us understand once again. This is very interesting thing you may like. Um, so the activity says, Charis,
Mhm.
listen to me. So the activity says like you need to take some amount of water. You have taken already, and then you are adding some salt or sugar. You have added salt this time, very good. And then you just start changing, start observing the change. So in the beginning, you told me like there was a kind of slight change in the level, but what happens when you actually stir it? The water level seems to be same. You know why it is happening? Because when you have added salt, it has not been dissolved earlier. Was the salt dissolved properly earlier? No. As you told, it was at the level down at the bottom. You could see that, right?
Mm-hmm.
But when you stirred, when you started stirring, the salt particles started getting dissolved into water, right?
Yes.
So when we are magnifying the water, we see there are millions of particles, million times of particles, right?
Yeah.
So is there a space in them? Like particles are little looser than solid. There is a space in them or not in liquid?
No.
Like if I just zoom it in, can you see there is a space or not?
Yeah.
So there is a space between the particles of water. That is true or not?
Yes.
And as you add salt into it, what do you see? Like this space is being covered, right?
Yeah.
Do you see this? Like this is now water and this is salt, this orange one, right? Do you see this third
Um.
figure? Can you see this third figure? This one?
Yeah.
So what is happening here? This salt, the particles of salt is being, balanced between those spaces of water particles, right?
Mm-hmm.
So, because there was already space between the particles of water and it occupies that space, that is the reason the salt does not increase the level of water because that is now adjusted and completely dissolved. Do you understand that?
Yes.
So, that is the observation. Now, did you understand this experiment or not?
Yeah. Think
So,
so.
what did you understand? Just explain to me.
So the water have particle in it, and
Hmm,
then when the salt go in,
hmm,
it's solid, so it fill up the space.
hmm.
But when you stir it, it become a hole.
Yeah, it gets dissolved with the water.
It get
It
to
gets yeah, liquefied, and the space which was there already there in liquid form, the particles of water, that is being occupied, so it does not seem to increase the level, right?
yes.
So this is what we understood. So whenever you add some solid stuff or whenever you add something which can be dissolved, if you add something which cannot be dissolved, then the level of water would increase dynamically. Okay, so you have, let us do this experiment. You have this water with you. Do you have anything near you, either pebbles or marbles or anything which is solid but cannot dissolve in the water? Do you have anything near you?
Like as in what? Like cannot dissolve into water.
Hmm. Do you have
Call
anything like that is in solid form but cannot dissolve? That could be anything, coin or anything.
um
Coin, pebbles, marbles.
this thing.
What is this?
It's
Plastic?
like yeah.
Uh, we need something more. Like this would not affect. This would float on the water, like something very solid.
Oh coins.
Coins can work.
Okay. Do I have to go get it?
Yeah, please do first.
Oh, ah, got it.
Yeah,
And then put it into
yeah, yeah. Just show me as well when you're
this
keeping.
thing.
Yes. Yeah.
Just put it in there.
Yeah, you can take the spoon out.
Yeah.
Yes. Now just hold it above. Yeah.
Do I drop it in?
Yeah. So hold it, then just show me first, then I'll just
Yeah.
hold it. Yeah.
Like this.
Yes, very good. Just leave it down. Yeah, very good. Yes. A little increase you can see now. Little increase in the level of water. Yes or
Yeah.
no?
Yes.
If you add more coin, do you have more coins?
Yes.
Okay, add some of them.
Do I just add all of this?
Yeah, you can. Okay, now pick
Yeah.
it up. What do you see
The
exactly?
increase.
Huh?
The increase and the
It,
mass is
yeah,
heavy.
yeah, very good. What if I ask you, can you stir them and would it be dissolved? Yes or no?
No.
Of course not. Why? Because that is much
Solid.
solid. Yeah. And that is not dissolvable like salt or sugar, right?
Yes.
So this is the difference. So water particles can be covered up with salt and sugar, but not something which cannot be dissolved into water, right?
Yes.
Very good. What if I somehow gets able to melt these coins? Would it dissolve then?
No.
If I melted the coins, melted means I turned it into liquefied form by increasing
Maybe.
heat.
Maybe.
Yeah, maybe, perhaps. So in that case, water may also, like if that is heated, then water may also be, turned into that would be having evaporation process. So it will turn into vapor when you are heating that. So we must gently add something which is dissolvable in water, so we may clearly see that level of water does not increase, right?
Mm-hmm.
Good, good enough. You did nice experiment today. Did you enjoy that?
Yeah.
Okay, let's go. So we understood some of the things, some key takeaways. You may note it down after this observation. That first observation, right? Write the observations. Observations after experiment, mixing salt into water. What is the experiment you've done? You have mixed salt into the water, right? Ex-
Yes.
Observations, my observations after mixing salt into the water. So what have you observed? Observation number one. Um, what was the observation number one?
Um.
I firstly saw a little raise into the level of water.
When the
Yeah,
salt is at
yeah,
the water rate rise.
yeah. The level initially rises when I add the salt into the water. The level initially means quite little.
Little.
Yeah. The level initially rises slightly with the solid salt. This is
Right.
observation number one. When I add the salt into the water, the level initially rises slightly with the solid salt, right?
Yes.
And what is observation number two? Right, observation number two.
When mix the salt
Yeah,
dissolve.
when the salt dissolves, when the salt dissolves,
Yeah.
dissolves, right?
Yeah.
The water level actually decreases slightly.
Slightly. Okay.
Yeah. Do you know the reason? We must also write reason in second observation. Because the salt ions spelling, do you know?
Yes.
ions. Yeah, because the salt
because the salt
ions
mm,
fit into the spaces between water molecules.
yeah
Hmm. So what happens? It fits into the
the
spaces between water molecules, right?
yes
Um, I can also say, mhm.
um
In the form of volume, what I can say, this observation in the form of volume. Listen to me, Caris, huh?
yeah
So, firstly, whatever the volume of water we could see, we could notice. And when we add salt into it, volume increases slightly more. But when we stir it, the volume gets to be same, right?
mm-hmm.
Volume means the total area being covered into that 3D glass, right?
yeah
Yes. So when you first put solid salt into the water, the volume goes up because salt takes up its own space, right? Just like
mm-hmm.
any solid object. Now you have done with coins as well. And when it dissolves, the salt dissolves, the sodium and chloride ions
yeah
separate, right? So salt is made of two things. Do you know the
Sodium,
formula of salt?
yes, yes.
What is that?
Sodium and chloride.
Chloride,
Chloride.
NaCl. So these tiny ions fit perfectly into the gaps of the naturally exist between the water molecules, that is H2O, right?
Yes.
So volume contraction we may see here because the salt particles occupy these empty spaces and the overall volume of the salt solution becomes less than the volume of the water plus
Yes.
the volume of the salt added separately. So it seems like both of the things are same, right?
Yeah.
So if you do not use precise measurement unit, it would not be um, noticed that the volume has increased or not.
Mhm.
Okay, so this is the experiment we have done. I have shared something in the group too after this experiment. You may read it later. Okay. Okay, so let's go ahead with something else. So you read this one.
How small are these particle matter?
Yeah.
Activity. Take 2 to 3 crystal of potassium per meg per
Permanganate.
magnet,
Permanganate.
magnet
Yes.
and dissolve them in 100 ml water.
Yep. Now read this.
Where?
This
Take
side.
out approximately 10 ml of this solution and put into 90 ml of clear water. Then take out 10 ml of this solution and put it in another 90 ml of clear water. Keep stirring the solution like this 5 to 8 times. Is water still colored?
Hmm. So this is something we may talk like take 2 3 crystals of potassium permanganate. Do you understand what is potassium permanganate or not? Hmm? Do you know what is potassium permanganate, child?
No,
Okay.
no.
Let us understand what is potassium permanganate. Okay. I may show you this. Can you see this search bar?
Yeah.
Hmm. So here, the formula for potassium permanganate, please note it down. The formula for potassium permanganate is what? KMnO for potassium permanganate. This is the spelling, potassium permanganate, and formula is KMnO4. All right, noted. This is the formula, KMnO4, potassium permanganate, right?
Is that all?
Yeah,
Potassium permanganate.
yeah.
Okay.
And what is the appearance like? It is a dark purple, nearly black, crystalline solid that dissolves in water to produce a pink to deep purple solution. When you are dissolving it into water, the color of water becomes what? Pink to deep purple, right?
Yes.
And solubility. Potassium permanganate is soluble in water, methanol, and acetone, and other organic solvents. Okay, so we understand this is something when you are adding into the water, the color of water may change uh, to or may turn to a pink or deep purple solution, right?
Mm-hmm.
So you may write formula KMNO4 you have written. Now you may also write appearance. It is a dark purple or nearly black crystalline solid that dissolves in water to produce a pink to deep purple solution.
Okay.
Done?
Mm-hmm.
Yes, so this is what the potassium permanganate is. So that's what we understood. Potassium permanganate. The formula for potassium permanganate is what? KMnO for K means K stands for what?
Not sure.
K stands for potassium. Mn stands for what?
Um,
Manganese. Manganese. And O stands for what? O.
oh, um,
O- Oxygen. Oxygen. Okay.
oxygen. Yeah.
Yes. Potassium, manganese, and oxygen. All right.
Uh-huh.
So let's come back to our booklet that is saying like 2 to 3 crystals of potassium permanganate and dissolve them into 100 ml of water, right? So what it's asked for us, it says like dissolve 2 3 crystals, the crystals you can see in this form. Hmm. Can you see this picture?
Mm-hmm.
This is the crystallized form of potassium permanganate, right? Hmm?
Yeah.
So the experiment asked us to take 2 3 crystals of potassium permanganate and dissolve them into 100 ml of water. How much water? 100
Um,
milliliter. Huh?
mm-hmm.
Yes. Okay. So now it asks us for take out approximately 10 ml of this solution and put it into 90 ml of clear water. Understand it very carefully. So this solution is of potassium permanganate with water, right?
Yes.
And we have taken out how much? 10 ml, right?
Yeah.
Okay. Take out 10 ml of this solution and put it into another 90 ml of clear water. Now, what it asked us, it said, like, firstly, you have mixed potassium permanganate, 2 3 particles. into the water of 100 ml. Then we have taken 100 sorry 10 ml out of that 100 ml solution, and then we have taken another clear water that is 90 ml now. Okay,
Yes.
and then it is asking us to add that 10 ml of solution of potassium permanganate with water into 90 ml clear water. Keep diluting the solution like this 5 to 8 times. Diluting means mixing this properly. um, is the water still colored? So um, listen, what is happening each time we are taking it out, we are putting it into uh, fresh water. So this process
Mm.
involves a kind of continuous observation, not only with potassium permanganate, but it can be done with some simple normal color too. So here is 100 ml water. We have added 10 ml, um, 10 ml the solution of potassium permanganate with water. So this is the color you see, the dark pink. Do you see that dark pink color?
Mm-hmm. Yeah.
Yes. And
Yes.
this is lighter than that. Do you see that?
Mm-hmm.
Hmm. And this is more lighter than that. Do you see that?
Yeah.
This is much lighter than that. Do you see that?
Yes.
This experiment you can also do at your home. If you do not have potassium permanganate, no worries. You can even choose the normal color you may have in with you in your home. What you need to do, just take a little bit of color, and then just keep it into 100 ml of water, and then whatever the water you have in that pot or beaker, you may take that 10 ml out of it and then add into some another pot which has fresh water. Then again, you may see the color may decrease. Again, take 10 ml out of that solution, then take another fresh water, then keep 10 ml into that fresh water. Then you would see the change. The color has decreased. It has been faded. And then again, you keep on doing this task, and then at the end, you may find like color is almost gone, right?
Yes.
Do you want to do this experiment?
Sure.
Do you have color?
Like food color. Can
Food
I?
color? Yeah, food color can be used. Even anything like that may be used for drinking beverage or what.
Okay. So I have to get 100 ml, right?
Yes, and you need to have another glass as well because we will
So
need at
five
least.
glass.
Yeah, yes.
Okay. Okay. So I don't know how to get 90 ml because the least that I could get is 100 ml.
Okay, no prob. We can continue with that too. You may show me like what you have around you. You may turn the camera, like you just flip the camera to back.
Yeah.
Yes. 1, 2, 3, 4, 5. Okay. And yeah, we can just have round of data. Like uh, you have around roughly same kind of water in each, right?
Yes, it's tap water, all of them.
Yeah. And you are having at the same measurement as at approximately same quantity in each.
Yeah, like 100 ml.
Yeah. Now keep that thing color, either edible color or whatever.
Okay. So how much water?
Just a pinch of color, pinch, a bit. Yep. Go ahead. Hmm. You may stir it with something.
Okay.
Good. Very good job. Yeah. All right. So the observation number one, you notice the color of this solution which you have mixed it into it. This is kind of red, hmm? Red in color,
Yeah.
right? Okay.
Yes.
Now you may take a little part into it. How would you measure? Like I would say, take three spoons. Okay, make it five or 10. I guess that would be more effective.
6, 7,
Mm,
8,
8, 9,
9, 10.
10. Okay. So 10 times you have taken into it. So you notice the color clearly, right?
Yes.
Hmm. Okay. This is much faded. I would like you to add 10 more spoons from that. Yes. 1.
3,
Yeah.
4, 5, 6,
Hmm.
7,
Hmm.
8,
Hmm.
9, 10.
Very good. So 20 spoons in total you have mixed into it, and the change in color can be observed properly, right?
Yes.
Now do the same with this solution. Take 20 spoons out of second glass and then add it into fresh water.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Very good. Now observe color change in all these three, like difference could be visible. Can you see the difference?
Yes.
Very good. Now do the same with next glass of water. Take out 20 spoons out of it and then add it into fresh water.
seven, eight, nine, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20.
Do the same with next glass of water.
2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Perfect, perfect. This demonstration has been perfect. Now you may keep them in a row, all of the solutions. Keep them in a row. Like the first one should be kept first, and then second one should be kept second, and third one in series. Okay. Yep. Yeah. Yeah. Okay. Now keep your camera and show me. Good. Good job. Yeah. So this thing, can you observe it properly? Take out the spoon. What do you notice in these? In
It
first,
goes from darker to
yeah,
lighter until it's almost clear.
almost clear, right? Last one you see like that is almost clear, right?
Yes.
Okay. Good experiment. Now let us come back to our class. Go to your chair. Yes. So we have done this experiment. Now let us write our observation out of it. You may write my observation after the experiment adding edible color into the water.
Okay.
Hmm?
Edible
Color
in
into the water. My observation after the experiment adding edible color into the water.
color
Into the water.
into the water.
Water. Okay. So you may write your observation. Firstly, at the first thing, what you did, first thing was what? You just kept how many things are required here. You have taken five glasses of water, right?
Take, yeah,
Write
take
it down. Yeah,
5 glass of water. 5 100 ml glass of water.
yeah. You have taken 100 ml of ml glass of water. Okay. So each contained 100 ml water, right? Approximately. Then second step, what did you do?
Second
What did
step, um,
mm, you added a pinch of
color, a
color
pinch,
in first
add
glass of
a
water, right?
pinch of color
In first glass of water.
in first glass.
Now, what is the third step you've done?
Um, take 20 spoon of
Of this time solution, right? 20
the
spoons,
first glass.
yes, 20 spoons of solution
Solution from
from the first,
first
yeah, first glass and put it into
um
Into the glass
into
of clear water, right? S-
a
Put it into the second
glass
glass of clear water. Put it into the second glass
of
of clear water.
water. Yes.
Now, fourth step, what you have done?
First step, so on. Can I just write so on?
Yeah, still on. And we did the same. Keep on going with the things in a series.
Repeat.
Hmm.
Okay.
Okay, so now comes the observation. After taking each amount, you may write it perfectly in more detailed way and you may send it to me in the group, okay? Right
Yeah.
now you're writing it in short, okay?
Yes.
So now what you observed in the first class? In first class, I observed the dark color, right? Good amount of color in the water, right?
Um.
Color was darker, and in second, it was lighter than the first one, right?
Yes.
And third, it was lighter than the first and second one, right? Previous two glass of
Mm-hmm.
water. And fourth, again, first and third, and first to third, it was lighter than first, second, and third. And final one, it was almost clear, right?
Yeah.
So this is the observation you have noted. Not really.
Yes.
Okay, so you may write it in detailed way and you may send it to me in the group, right?
Mm-hmm.
Okay. Did you enjoy this experiment or you found it boring?
Okay. It's fun.
It's fun. Not only fun, there is a lesson in into it, like why it is happening. Now let us counter this question. This experiment shows that a few crystals of potassium permanganate, we have taken color, not potassium permanganate because we did not have that, right?
Mm-hmm.
Can color a large volume of water, about 1000 liter. So we conclude that there must be millions of tiny particles, just one crystal of potassium per magnet. We can say there were millions of particles in that color you have taken, right?
Mm-hmm.
Yes. Which keep on dividing themselves into smaller and smaller particles. When you are adding it into clear water, it keeps on what? Dividing, right?
Yes.
And the same activity can be done using 2 ml of Dettol instead of potassium. We did not use Dettol, but we used what? Color.
Mm-hmm.
Dettol instead of potassium permanganate. The smell can be detected even on repeated dilution. The particles of matter are very small. They are small beyond our imagination. This
Mm-hmm.
thing we have observed, like each time when we are keeping it, it is being faded, but still there are some particles in the last glass of water too, right?
Mm-hmm.
So there was the particles of that color in last glass of water, but it was looking almost clear because those particles were so tiny that it was not visible to our eyes, right?
Mm-hmm.
Do you understand that, Karis?
Yes.
Okay, now you may go reading this characteristics of particles of matter.
Characteristic of particle of matter. Particle of matter have space between them. In activity 1.1 and 1.2, we saw the particle of sugar, salt, dental, or potassium permanganate got
Evenly means
evenly
equally, yeah.
distribute in water. Similarly, when we make
Distributed.
distributed in water. Similarly, when we make tea, coffee, or lemonade, particle of one type of matter get into the space between particle of the other. This show that there is enough space between the particle of matter.
Yeah. Have you ever taken tea, coffee, lemonade?
Yes.
Yeah. So same thing happens in that too, right?
Yes.
Those particles get dissolved into that, and this shows that there is enough space between particles of matter that it can cover up, right? So this is what we understood. Now particles on matter are continuously moving. This is what you may read activity number 1.3. Read it.
Mm-hmm. Put your eyelid in
Unlit. Yeah.
a lid insist stick
Incense stick. Incense stick, do you
instant
know?
no what is
Um,
like torch match or something.
stick. So this is kind of thing. Have you ever seen this earlier? No?
No. Oh yes, yes, yes.
What? What? Yes. How do you call it?
I don't know. I just like when I go to like temple stuff,
Temple of whom? Which temple?
like Buddha's temple. I don't know.
Sorry?
Like temple. I don't know.
You have gone to the temples?
Yeah.
Yeah, it can be found there. So this is kind of this material which you burn, then it has this kind of is fragrance as well, right? So
Mm-hmm.
this smoke you may see, this is full of fragrance. So this is what incense mm, stick is called. So put an unlit. Unlit means which is not lit, right? You've not given fire to it. Unlit incense stick in a corner of your class. Hmm? And
Mm-hmm.
how close do you have to go near it so as to get its smell when it is unlit?
Mm-hmm.
So the perhaps you are not understanding it. I may take another example. Um, do you use some kind of coils or anything for refraining mosquitoes?
Um.
No. Or room
No.
freshener? Do you ever use room freshener?
No.
Nothing. Have you listened about room freshener or something?
Yeah. Yeah. I heard.
How shall I make you understand? Wait. Do you know about this? All out mosquitoes guard. Do you know about this kind of stuff? Mm, this thing. Do you know this thing? Look at this. Do you know this thing?
Um. Yeah.
What is the use of this?
Um. To keep mosquito away.
Yeah. So when you connect it with the electricity, it gives the kind of fragrance and what. But when you are not connecting it electricity, then does it give fragrance to you in the room?
Uh. I don't know.
Haven't you ever used this?
No.
That is the problem. No problem. But you know that, right?
Yes.
Okay, so this is something like when you are burning something and when you are not burning something. When you burn it, then it gives fragrance to the room. But when you are not burning it, it is the fragrance is limited. You have to go near to take the fragrance. Okay. So now light the incense stick. What happens? Do you get the smell sitting at a distant distance? Of course, we get that and record your observation. So this is activity which is unfamiliar to you because you do not know about incense stick. Now activity number 1.4. Take two glasses or beakers filled with water. You may read this.
Um. Take two glasses slash beaker filled with water. Put a drop of blue or red ink slowly and carefully along the side of the first beaker and honey in the same way in the second beaker. Leave them undis- undisturbed
Undisturbed.
in your house or in a corner of the class. Record your observation. What do you observe immediately after adding the ink drop? What do you think you observed immediately after adding the drop honey? How many hours or day does it take for the color ink to spread evenly throughout?
This is a good experiment. It asks us for taking two glasses of um, filled water or beakers. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and on honey in the same way in the second beaker. Leave them undisturbed in your house or in your corner of the class. Record your observation. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? And how many hours or days does it take for the color of ink to spread evenly throughout the water?
Mhm.
This experiment you may repeat at your home because this will take time to observe. Did you understand what is the experiment?
Yes.
What you need to do, just let me know.
Um, like two glass,
Hmm.
fill with water,
Hmm.
then drop like ink carefully along the side of the first
Side,
beaker.
like this is the glass, this is the glass. So this side I have to drop the ink like this side,
Oh,
right?
okay. Okay.
Yeah, right? This side.
Yeah.
So, yeah, that is transparent, and we will keep it undisturbed. And same we'll do with another glass. We will drop honey from this
Uh-huh.
side, right? And we'll
Yes.
keep it and we'll wait and watch that what is happening, how long it takes to dissolve completely, right?
Okay.
We will not stir it, we will not disturb it, right?
Mm-hmm.
Hmm. You may do this experiment, you may take a screenshot, and you
Okay.
may do this experiment tomorrow. We are having holiday, so you may do this experiment and you may write your observation and send it to me, okay?
Yes.
Do you have honey and ink at your home or not?
I have ink, but I'll try to find honey.
Okay, you may do this. Now 1.5, activity 1.5.
Okay.
Have you taken a
What?
screenshot of this?
Yes.
Okay. Yeah, this one.
Um, drop a crystal of copper, sulfur, or potassium permanganate
Mm-hmm.
uh, into a glass of hot water or another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe just above the crystal in the glass? What happened as time passes? What does this suggest about the particle of solid and liquid? Does the rate of mixing change with temperature? Why and how?
So for this we have to understand what potassium permanganate. I also made you understand. What about copper sulfate? Do you know copper sulfate? Formula of copper sulfate too? Hmm? Child?
Um,
Yeah.
I don't know. I'm
Okay.
not sure.
Please write the formula. This is how it looks like in this form, and here is a structure. So copper sulfate or copper um, sulfate is an inorganic compound with the formula CuSO4. So we have copper, we have sulfur, we have oxygen, right? Widely used in agriculture, industry, and as a trace mineral supplement. So write the formula of copper sulfate. That is copper sulfate formula. That is CuSO4. CuSO4. Copper, sulfate, and oxygen. Right? There are three
Hmm.
things. Understood?
Yes.
Very good. But we do not have any of these. Neither we have potassium permanganate nor we have copper sulfate. So we would skip this skin thing. We'll be understanding it from another angle, from something else. So you may read theory, by the way. Yeah. What does it say? Read from here. Yeah. Charis. Yeah. Go ahead. Particles. Ah,
Particles of
mm,
matter are continuously moving. That is, they possess what we call the kinetic energy. As the temperature rises, particles move
wait.
fast.
Yes. This is something we got this term, kinetic energy. So now we have the definition to kinetic energy, right?
Yes.
So what is kinetic energy?
Um. Wait, I think I know, but I think I forgot.
Okay. Would you able to recall or
Not sure.
kinetic energy? Kinetic energy. Write the definition now. Write the definition. Hmm. Kinetic energy is the energy that an object possesses due to its motion. Hmm.
Can you go back again?
Kinetic energy is the energy that an object possesses due to its motion. Kinetic energy is the energy that an object possesses due to its motion.
Mm-hmm.
Okay, so that's only the thing you may remember. Later on, we may discuss like it is defined as the work needed to accelerate an object. Accelerate. Have you ever seen a car or a bike accelerating? Charis. Have you ever have you ever had a ride on a bike?
Yes.
So there is accelerator in the bike, right?
Yeah.
So when we move that accelerator, the what happens when we move the accelerator in this direction?
Um.
Do you know riding bike or scooty, perhaps? Do you know riding bike or scooty?
Yes.
The bike with accelerator, right, or without accelerator?
Um.
Are you doing something right now?
No.
I have a question. Like, you know riding bike with
Yes.
accelerator or without accelerator?
The one that you can like um
This
pull
one?
to brake,
Um, okay,
or like the motorcycle.
not motorcycle. You're talking about this bicycle, right?
Yeah.
I'm talking about this.
Oh, motorcycle.
Have you ridden these things like this or this
Yeah.
something else? No, but you have
I ride on it, but like I didn't drive.
this one you've ridden, right?
Yes.
So this does not have accelerator, but paddles, right?
Yeah.
This is called bike and this is called motorbike. I'm talking about
Mhm.
motorbike basically.
Okay.
So when you're talking about acceleration, this has something to do with kinetic energy.
Okay.
So that's what particles of matter are constantly moving. That is, they possess what we call kinetic energy because they are also moving. Okay, go ahead.
Um.
Go ahead, Karis.
Particles of matter are continuously moving. That is, they possess what we call the kinetic energy. As temperature rise, particles move faster, so we can say that with increase in temperature, the kinetic energy of particle also increase. In the above three activity, we observe that particle of matter intermix on their own with each other. So they do so by getting into the space between the particle. This intermixing of particle of two different types of matter on their own is called diffusion. We also observe that on heating, the fusion also become faster. Why does this happen?
Hmm. Now go ahead.
Particle of matter attract each other. Play this game in the field make for a group of and form human chain. As suggest, the first group should hold each other from the back and lock arm like
Idu
Indo
Mishmi dancers. This is something.
Indonesia.
Okay. The second group.
Um, the second group should hold hand and form a human chain. The third group should form a chain by touching each other with only their fingertips. Now the fourth group of students should run around and try to break the three human chain one by one into as many small groups as possible. Which group is the easiest to break? Why?
So can you just let me know which group would be easiest to break? The first, second, or third?
First,
And first one would be easiest to break.
no wait.
First group is like that. They have locked their arms.
Yeah,
And
first group is hardest.
yes, and second group is
The middle,
yeah, and the third easier,
the
much easier, right?
yes.
Can you just imagine this can also demonstrate the three forms of matter, solid, liquid, gas, right? Isn't it?
Yeah.
Okay. All right. So this is what we have done so far, and let's go with this. If we consider each student as a particle, read this. Charis.
Um,
Yeah, read from here. If
if we consider each student as a particle of matter, then in which group of the particle held together with the maximum force?
first, second, or third,
Um,
maximum force.
first.
Hmm. Next, read this.
Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammering, cutting, or stretching. In which of the above three substances do you think the particles are held together with greatest force?
Did you understand this experiment?
Iron nail and a piece of chalk and a rubber band, breaking them by hammer, cutting, or stretching. And which one is like greater force?
Did you understand the experiment or not? Let me know first.
Yes, yes.
So, which one would you be able to break easily? Chalk, rubber, or piece of chalk? Sorry, nail, iron nail. Iron nail, piece of chalk, or rubber band with hammer. Which one would be easier to break?
Um, piece of chalk,
Very good. Good, right answer. And after that,
rubber band,
and much difficult would be
iron nail.
why? Why is it this so?
Um,
Mm,
because
mm, because
the iron nail is much more harder and dense.
yeah, very good. Are you writing something, Karis?
No.
Read this.
Take some water in a container. Try cutting the surface with of water with your finger. Whenever hot the first surface of water, what could be the reason behind the surface of water remaining together? Because you cannot cut it because the water like it's like you dipping your finger in, but then the water is like you have to take it out. Oh wait, actually, because the particle is near each other, so yeah.
Because whenever you're trying to cut and you keep your hand up, the particles connect again, right?
Yes.
So they are in kind of form, like they are moving all together and they have some space into it. So when you keep the hand,
Mhm.
so that space is being occupied, but that does not be like the surface is not doesn't cut off, right? So this is what. So the above three activities from 1.6 to 1.8 suggest that the particles of matter have force acting between them. This force keeps the particles together. They have a force. The strength of this force of attraction varies from one kind of matter to another. The force may vary, like it depends on the kind, like they are solid, liquid, or gas. Uh, Take the screenshot of these questions. In the homework, you'll be doing this.
Okay.
Have you taken the screenshot?
Yes.
Okay. Um, so we'll be talking more of this state of matter and then more activities it will be filled with. Um, is your mom near?
No.
Says again, out.
Yes.
She has started going on the work, right?
Yes.
Okay. All right. So I'll communicate with her next time. Do you have any doubt?
Um, no, I don't think so.
Okay. How did you like today's class? Quite
Okay.
boring, right? Quite boring or full of
Okay.
fun? Not fun? Which
Um,
part? Which part did you enjoy most?
the experiment.
Experiment. Anything else?
Um, no, I don't think so.
Okay. You're tired now, right?
Yeah.
Okay.